So today we are going to start off with a new strategy, which is Bollinger Bands. We will talk about pivots, but band. We are going to talk about both today, Bollinger Bands, to start off right now. Whoever formed these theories, most of them are not alive today. But Mr. John Bollinger, who framed this theory, is alive even today. So this is comparatively a newer theory. Okay, so just for your theoretical purpose, if you want to write down, the person who came up with this strategy was Mr. John Bollinger, and of course he has named his theory with his name, Bollinger Band. What he focuses on is the concept of, if you remember I had talked about this, his theory is based on the concept of standard deviation. Okay, so what I did was, actually I thought that I should give you a proper base for that also, some mathematical base. Okay, so I have done my homework. I can also show you, teachers also do homework, maybe more than students. And I tried to, yes, believe it or not, I have done my specialization in statistics while doing BCom. I hardly remember anything. But I opened my books and I tried to find out how we used to do that when I was doing BCom. Because Bollinger Bands can be more appreciated if you understand the theory of standard deviation. Otherwise, again, if you want, I can tell you the direct strategy. This above this, by that below that, sell. Khatam. No, but I feel one example is worth it to understand what is the concept of standard deviation. Yes. So what I did was, let us say I'm plotting this stock prices. Okay. And I took 10 observations. I'm talking about, let us say, stock X, and the 10 stock prices can be 59, 55, 51, 55. If you want to write down simultaneously, it is okay, so that will not waste time afterwards. 52, 53, 54, 57, 58. This is observation, so this is days. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's no rule for 10. I've just taken 10 observations. That's it. Oops, sorry. Okay till here? Yes? So what do we do here is, first of all, in typical statistics, 10 is known as N. N is number of days, number of observations. Okay. Is it necessary that N has to be 10? No, N can be any number of observations that you are taking. In our example, we are taking 10 days observation. So N is 10 in our example. All these stock prices, I'm saying, let us say X is the price. We have learned this since 8th standard. Say X is the price. Okay. So we are getting all this as a summation X. Those who have learned statistics. That E kind of a thing that I'm drawing, that is known as summation. So I take a summation of this entire X, and this summation X comes up to 550. Okay. Done till here? Now if I were to calculate an average of this, how do I calculate an average of this? Divided by, okay. So X bar is what? Average basically is 55. Is this okay till here also? Summation first I took, and then I took an average of that. X bar is 55. Okay. Now what I try to do is, in the next column, I try to calculate X minus X bar whole square. Wait. Don't get panicked. Let's forget that whole square right now. X minus X bar means what? I am trying to calculate. Okay, first of all, what is X bar? It's like the average. Okay. Have we talked about averages in our batch? Dema. Average. It's an average. Like 20 dema, 5 dema, 13 dema, 26 dema. We are talking about 10 DEMA right now. Okay, so we are talking about an average. Now what are we trying to calculate? On an average, if it is 55, so what is on an average 55? The stock price on an average on a 10 days duration, if it is 55 on an average, question is how much is it deviating from the average? How much it is deviating from the average? Again, I'll give you a cricket example quickly. Whenever we talk about any batsman's average is calculated. How is batsman's average calculated? Number of runs scored in every inning divided by number of innings. And when we say Virat Kohli's batting average right now is, let us say, 90. What does this mean? On an average, he has scored 90 in every inning. Okay. Does it mean he will score exactly 90 every time? No. Now what are we interested in? How much does he deviate from his average? That is what we are interested in now. Correct? Yes. What would be the case for Virendra Sehwag? 90 average possible. Correct? But deviation would range from 0 to 300. Okay? But if I am talking about Virat Kohli in the last 2-3 years, he should be very close to that average. Are you with me? Yes. So now what are we trying to calculate? What is x minus x bar? X minus x bar is nothing but we are trying to calculate how much the stock price has deviated from its average. How much plus or minus deviation is there from the average? Is it okay till here? Yes. So x minus x bar, it's very easy to calculate now. 4, 0, minus 4, 0, 1, minus 3, minus 2, minus 1, 2, and 3. Okay. Now the important point is that, so I hope you have understood the meaning till here. What is x minus x bar? The stock is moving away from the average by this number. Okay. Now, statistics says that if you want to calculate a proper standard deviation, then deviation, whether it is above or below. See, if I take a summation of this right now, this is going to be 0 now, ideally. Yes, this has to be 0. If I take a summation of this, see, this plus 4 minus 4 is getting knocked off. Minus 3 plus 3 is getting knocked off. Minus 2 plus 2 minus 1 plus 1. All knocked off 0. Okay. But then this is not giving me any interpretation as such. So I want to actually ignore that minus sign. Okay. Statistics says now try to ignore that minus sign. How can I ignore that minus sign? Can I do a square root? I'm sorry, can I take a square? If I take a square, minus sign is gone. We have learned this in primary school, minus minus plus. Correct, whatever standard. So now what we do is x minus x bar square, so that minus sign is gone away. So how much this will be now? 16, 0, 16, 0, 1, 9, 4, 1, 4, 9. Correct? 32, 42, 52 plus 8, 60. Correct? But then we have taken square only for the purpose of doing away with that negative sign. So I don't want that square na actually. So if I don't want the square, I'll take a square root. Oh my god, this is too much of algebra, isn't it? But I hope it's simple. One more time quickly. Minus kadun takaयचं मग. But then I think it will give a different answer. It's just 0 na? Okay, so if you add this up, it will give a different thing only. 4 plus 4, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. The answer comes different. There might be some more statistics behind that also. Maybe I might have kept that for option. Uska square root should come same, is it? We'll try it out. We'll try it out. So now what is to be done? We are going to take, okay, by the way, this 60 is of all these things, na? Okay. So we don't take a plain square root, but we take 60 by n. N is number of observations. Number of observations was what? 10. So this is basically 6 ka square root. What is 6 ka square root? Take on calculator. Huh? 2 point something. Take on calci. 2.5 roughly will take. Anyone can do that? 2.5? 2.5 exact है का एवढं नाही ना 2.45. So we'll round it off to 2.5. Okay? Yes. My God, what all did we do? And then the answer would be different. Huh? Because in your case, if I directly add this without considering the minus sign, it's coming square root of 2. Because I do square root of 20 divided by 10. So that would come different. Okay. So, of course, I'm not a mathematician. So I don't know why this is done. Okay, but the logic behind this is take the square so that the minus sign is gone. And if you again take a square root, we come back to the original. But finally, we are dividing it by n. What is n? Number of days. Okay? Simple till here? Yes. 2.49 something. So we are rounding out 4.45. Okay. But again, for me, I have to do few more mathematical calculations for the 2.5 rounding off is simpler for me right now. Wait. I'll tell you. So without looking into this, tell me what did we do? Step number 1 was what? We plotted all the stock prices. For how many days? 10 days. So my n was 10. Okay. Step number 2, what did we do? We tried to calculate the average of all these prices. Step number 3, what did we do? We tried to calculate deviation from average. How did we calculate deviation? So average was x bar. Correct, na? So how did we calculate deviation from average? X minus x bar. But there is some in plus, some in minus. Okay. So to do away with that minus plus confusion, what did we do? Take a square first. See, if we multiply by the same, minus is going to be plus. So all in pluses will get. Okay. And to do away with that now, because we have unnecessarily squared it, now we take a square root of x minus x bar square, whatever answer we have got, but we'll divide it by n, which is the number of our observations. This is finally standard deviation. Okay? Fair enough till here? Okay. Now why did we do all this? Let us understand. So so if you again have learnt statistics, this is sigma, and this is your deviation basically. Okay. Our sigma deviation is coming to 2.45, but I'll round it off to 2.5. My oral math is not that strong, so that I can quickly do some calculations at 2.5. Okay, now again, for those who have learned a little bit of statistics, this was something known as a bell curve. Huh? Which curve? Gaussian curve. Gaussian curve. Maybe this I had kept for option when I was doing BCom. I remember bell curve, or maybe Gaussian curve, whatever. Okay, remember this type of curve. Okay, now what does this say? Remember something like this back in your school days. Okay, so this is your, basically you can call this like your median, your average, base average. And it's coming to what? X bar is, tell me. X bar? 55. Correct? Now what statisticians say, they have done a lot of backtracing like we do for technical analysis. They say that if I talk about 1 sigma away from this median, okay, Away from this x bar, if I'm taking one deviation here, one deviation here, so it will come to what, tell me? 55 minus 2.5 deviation, na? See, again, this is what? This is your average. This is like your DEMA, na, in short. In simple words, what is 55? It's like your DEMA. It's your average. It's your median. Correct? And from that, we are trying to deviate with the standard deviation. One standard deviation. That will come to 52.5 and this will come to 57.5. Correct? Yes? So this is one deviation plus one deviation minus. Now, statisticians say that 34.1% of observations will fall into this slab of one deviation. My God, he's saying out. Just tell me the strategy, finish it off. Okay, don't get scared. इसका total क्या आता है बताती हूँ. First understand this, 68.2%. 68.2% means what? Out of 100 observations, 68.2% observations will fit into this price band. Out of 100 stock prices, if I plot, 68.2, so 0.2 let it forget, 68 observations, 68 days, it will fit into this band of one deviation. Means what? If Virat Kohli's average is 90, okay, then plus or minus one deviation, okay, 68 innings will be within that range. That's the probability. Yes? काय करायचंय सांगणार आहे ना. Okay, one deviation is clear. But if you know, Bollinger Band standard is always at 2 deviations. BB is always 2 deviations. Now second deviation. Second deviation I'm putting it here. So this is minus 2 sigma. This is plus 2 sigma. Now what mathematicians say? This is an additional 13.6%. 13.6%. Okay. Wait. Now if I do this, 13.6 into 2. Plus 34.1 plus 34.1. Plus 34.1. 95.4. Okay. I hope those who are trying to understand this from the beginning, this part, this entire observations ka part, this much, covers how many observations? 95% of the observations will fit into this category. Out of 100 innings played by Virat Kohli, if his average is 90, plus or minus 2 deviations, 95% innings will be in that range. In simple words, he getting out on 0 will be only a probability of 5 innings. Yes? No? Little bit yes? This is hardcore mathematics. 5%. One last time, understand this. First, what did we do? So I'm going to compare cricket and stock market back to back. Okay, let us say I've taken 100 observations, 100 days observations or 100 innings observations. First of all, what did I do? I calculated runs for all 100 innings. I want answers from you all. Calculate all 100 innings ka runs, then take a average. Okay, so on an average, Virat Kohli scores 90 runs in the last 100 innings. Okay, can I say average is nothing but like your DEMA? Correct? Your DEMA is 90. Now, are we interested in only DEMA? No, we are interested in DEMA se kitna deviate ho raha hai. How much deviation is there from DEMA? So what do we calculate? X minus X bar. But then we'll get in plus. We'll also get in minus. To remove that, what did we do? Square. And then finally took a square root while dividing by number of observations. Because we want for 1. Na? We want for 1. If we don't divide, in our example, for 100 innings, we'll divide by n is 100. For 100 innings, we'll divide by 100 because n is 100. Okay? Yes? Now, if we calculate this, and if our sigma is coming to 2.5, okay, in cricket it can't be 2.5. You can't score 2.5 runs, correct? So in cricket, if I say Virat Kohli's standard deviation comes to 3 and average was 90, who can tell me what does it mean? Virat Kohli's DEMA was 90 and standard deviation is 3. Very good. 87 and 93 is upper band and lower band. So there are total 68.2% chances or 68.2 innings we can say wherein he will score in this range. Out of 100 innings, in 68 innings he will score in between this 87 and 93. Okay, yes. And if I take a 2 deviation now, 2 deviation will be what? 84 and 96. 84 and 96. 6 does not want to come on my screen. Okay, 84 and 96. Now who can tell me what is this? This accounts for how much? 95%. So out of 100 innings, he will score somewhere between 84 to 96 on 95 of his innings. There is 5 innings which he may get out on 0 also. Anything below 84, anything above 96. 5% chances. Better. Much better. Okay? So we are going to talk about that 5% chance now. It can't, so statistically, backtesting wise, this accounts for 95%. Then understand. First of all, how did we calculate 90? X bar, how did we calculate 90? That was average of 100 innings. Now, as and how you go on increasing the number of innings, if you're doing a moving average, this average is also going to change, na? So then your chances of going here and there is also going to change. Correct? Yes? Going to our stock price example now. I want a quick answer now. I took, let us say, 26 DEMA of a stock. I took 26 DEMA of a stock. What is that? Can I say this is like X bar? Everyone now? Is this a X bar? Yes. If it comes to 50. If X bar comes to 50. And if my sigma is coming to 5. If my sigma is coming to 5. How did I calculate sigma? For that I told you, it's square root of x minus x bar raised to the power 2 divided by n. If my sigma is coming to 5, what will happen? Tell me. In the bell curve. If this is 50. 45. 55. 68% chance that it will stay here. 2 sigma is what? 40, 60. 95% chance that it will stay in this zone. Correct? Everyone agrees? Now understood? In a much better way?